Perfect. Okay, well, thank you all for coming this evening. Today, we're going to go over some of the most common benthic macroinvertebrates that we find here in New Jersey. This is by no means a complete comprehensive list of everything that we might find out in the streams. But I want to kind of give an introduction to some of the more common things we might find. And then on Saturday, we will get our hands-on experience actually sorting our samples, pulling out the individual organisms and going through those identifications as a group. But first, just as a reminder, why are we looking at macroinvertebrates in the first place? These guys, they live in the streams for, it could be a couple months up to a couple years. So they are in the stream for quite a long time. And that is different than when we take a chemical measurement. We're going out at one point in time, we're putting a meter in the water, and we are recording exactly what the dissolved oxygen is, at 6:03 p.m. this evening. But when we're looking at macroinvertebrates, we can kind of assess the long-term quality of that stream by looking at the community of the macroinvertebrates who are thriving there. Also, these guys are stationary. They stay pretty much in the same general area of the stream. So that also gives us an indication as to what's going on locally at that particular spot. They are easy to collect. I hope you agree. And the protocols that we use are pretty standardized. So hopefully when you're actually out starting to collect the bugs, you feel comfortable and confident when you're out there. And lastly, all macroinvertebrates, all taxa have a pollution tolerance value associated with them. So the pollution tolerance value can range from 0 all the way up to 10. And that's sort of equivalent to saying a particular macroinvertebrate can tolerate 0 pollution or a lot of pollution. The ones that really can thrive anywhere have a much higher pollution tolerance value. That said, we don't just want to find the organisms that have low pollution tolerance values. We just want to find the organisms that have low pollution tolerance values in conjunction with those that have high pollution tolerance values. So we want to see that diversity, but we want to also see that the organisms with low PTVs can survive in that water. As a review, here are some of the common ones we might find with a high pollution tolerance. We have aquatic worms, leeches, and blood red midges. If you are assigned a site that is fairly impaired, this might be all that you find. If you are out at a site that may have some moderate pollution interference with the water quality, you may also find dragonflies, hellgrammites, or net spinning caddisflies. These all fall into this moderate pollution tolerance value category. And then in our low pollution tolerance value category, the bugs that are most wanted, that we really want to find in conjunction with everything else, are the stoneflies, the mayflies, and the case-building caddisflies. Now, we're going to go into a few different taxonomic levels today, but I just wanted to give a refresher on what the taxonomic classification system is. The more specific that you get, the further down this pyramid you go. So at the highest level, you have the kingdom, Animalia, all the animals fall into this kingdom as opposed to like plants or fungi. And then you get smaller and smaller and smaller. When we get down to order and family, that's where we're going to stop. So we're going to identify our bugs down to the order and the family level, and that is sufficient for our purposes. That said, there is still some diversity within those orders and families. For example, the mayflies, there's 19 families that exist in the world and over 2,000 species. So you can imagine when we're identifying one family of mayfly, there could be a ton of species underneath that category that may look different. And so not every mayfly that falls in the same family is going to look like other mayflies in that family. But there are specific things that we'll be looking for to help make that differentiation between these different taxa that will help us identify where this particular organism falls in the grand scheme of things. And this is the grand scheme of things. This is our macroinvertebrate tally sheet. This is basically what you will have next to you when you're in the lab as you're pulling out the organisms from your tray and sorting them. You're going to identify them and just put a tally next to each of these different families or taxa that you find. So today we're going to go over most of these sections, primarily the text at the top, this bold text. You can see at the top it says Coleoptera. So Coleoptera is the order, and then everything that falls below that are the specific families. And then so it's the same here. Diptera is the order. That's the order of all what we call true flies. And then we have the specific families that fall in that order below there. So it's organized so that the names are written down for you. You don't have to try to spell something like Hydrocyclidae. It's there. You just need to tally right next to it. So we'll go into an introduction into those main orders. And this is a general overview. And on Saturday, we'll get a little bit of a closer look at the families themselves in these orders as we practice with our dichotomous key. All right, so first I'm going to be using some, anatomical terms. So I figure this is a good time to kind of review what is an insect. So an insect is generally built of three parts. We have a head at the top. We have a thorax just below that. That's usually 3 segments below the head. And below that, we have the abdomen, and that can be fleshy, or it can have sort of this hard chitinous coating. So in this particular drawing, this sketch, this is a net spinning caddisfly or a Hydrocyclidae. And we see that we have this hardened plating right on the head capsule and on each of these 3 thoracic segments. And the rest of this is pretty fleshy. We also have abdominal gills on the underside or ventral side of the insect. And we have gills at the end of the body as well, with a pair of prolegs. Now, what's the difference between prolegs and jointed legs? Now, in this next illustration, here we have a Heptagoniidae. This is a type of mayfly. We have jointed legs, and this is just like our own. We have our forearm and our upper arm, and it can bend, and we have hands and fingers and toes. That is a jointed appendage. That is in contrast to a proleg. And the bottom sketch here, this is a Chironomidae or midge fly larva. It has not developed jointed legs. It's kind of adapted to just really need these prolegs in its larval stage to kind of, maneuver its way around. So prolegs are just kind of smaller appendages that the insect might use to maneuver. But jointed legs, those are the insects that can really crawl around and have more control over where they go. All right, so starting with mayflies. Mayflies in particular are about 1/4 of an inch to an inch long, and that's a pretty standard size for most of the organisms that we will find. With the mayflies specifically, we've got the head, we have the thorax. On the thorax, we may have a pair of developing wing pads. And so I'm going to just pull the mouse here. The wing pads are these sort of triangular shapes on the back of the insect's body. What this is because this is a juvenile stage, because this insect is young and it's developing, and this particular insect has an incomplete life cycle. So what that means is it's not going to pupate. It's not going to basically turn to mush and come out looking like a totally different insect when it emerges as an adult. The mayflies instead, they have their wings developing underneath their exoskeleton. And so these wing pads, as the mayflies grow, those wing pads are going to become more and more obvious on the back. So you can definitely see them here, these triangular shapes. And what is also particular to the mayflies is that they will always have gills along the side of the abdomen. So these are these kind of branching bits coming off of the side, both sides of this abdomen. There are some organisms that look like the mayflies, like the stonefly, but the stonefly will never have gills along the abdomen. Instead, it has gills under each thoracic segment. So we call those hairy armpits for stoneflies. But for mayflies, gills along the abdomen. And at the end of the body, the mayfly will end in either 2 or 3 slender tails. So these are these appendages at the end of the body. Now, because we're just looking at the order, of course, there's a lot of variability in the different families and the different genera that we might find. And the body structure will change depending on how that organism lives, where it lives specifically in the stream. So you can see, we have these, we call them buff dudes, the clingers, the crawlers. They have these big arms so they can crawl around on the rocks and they're very nimble. Other mayflies are more adapted to swimming. So they kind of have this arch to them. And they kind of just look like, they're going to move through the water like fish. Or we might find burrowing mayflies that have these tusks attached to the top of the head that allow it to really burrow down into the sediment. So here are a few other examples of mayflies. You can see the gills along the side of the abdomen can vary. Sometimes they can be wide and circular. Sometimes they can be branchy and forked, like in the bottom picture. Same goes for those tails, so that they will always have 2 to 3 tails, but they can look different. So the one up top, we have this band down the center of the 3 tails. And we kind of see there's even some kind of feathery bits in between the tails as well. While the mayfly on the bottom here, they're just long and really slender, and so they look totally different, but they're in the same category. Also, the gills on the abdomen can look a little bit different as well. So what we've seen so far, there's very obvious branching gills coming off of the side of the abdomen. In this example on the top, the gills are sort of coming off of, are confined to the top section of the abdomen. And the gills are kind of on the top of the body, so that, the dorsal part of the insect. And you can kind of see this featheriness. If we were to flip this insect on its side, you could see the feathery gills coming off the top. In this bottom example, the gills are these square appendages, also just at the top of the abdomen here. So these gills are more rounded, they're bigger, they're not coming off of the side and branching, but there's still that soft tissue. So when you put that critter under the microscope, hopefully you can tell that is made of a different type of tissue than the rest of the body. Now, when you see the mayflies in person, you will likely see their gills moving. I mean, this is how they survive. They need to move those gills to get oxygen. And basically, what we do is we put these insects into ethanol and we preserve them. So we will not have the benefit of looking at how the organism moves to help us with our identification. So we'll have to rely on other things, looking at the actual body structure. And here and on these examples, these mayflies have very developed wing pads. So we would be able to tell that these are later instar organisms, or they've been in the stream for a long time and they're kind of growing and growing and growing. And their wing pads are huge. They're about to crawl out of the stream and become adults. But I wanted to show this also because the mayfly on the bottom only has 2 tails. And that is totally normal for mayflies. to have either 2 or 3 tails. There's kind of this misnomer about mayflies that they always have 3 tails. That's not the case. They can have 2. So on our data sheet, once you are looking at an organism and you decide, yes, this is a mayfly, here are the next options that you'll be able to run through. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different options of families that we commonly find in New Jersey. And so the keys that we'll provide you with on Saturday will help you to, fine tune your identification even more. Stoneflies look similar to mayflies, but again, they will not have the gills along the side of the abdomen. The gills are confined to the thoracic segments. And you can see a bit, we have those hairy armpits underneath each of these pairs of jointed legs. Something else that is helpful to distinguish the mayfly from all these other organisms is we see at the end of these jointed legs, this stonefly has 2 tarsal claws. So you can kind of see it's like 2 toes at the end of the leg. The mayfly will only ever have 1 tarsal claw, 1 toe. Pretty much everything else we'll find will have 2, including the stonefly. The stonefly will only ever have 2 tails. So the stonefly will never, ever have 3 tails. If you find an organism with 3 tails and you're wondering between the 2, that is a very helpful indicator for you. Now, the stonefly is also, compared to the mayflies, which tend to have the eyes right on top of the head, the stoneflies tend to have the eyes, they're more widely separated and on the side of the head. Another thing to consider with the stoneflies is that their antennae tend to be much longer in relation to their body length. So mayflies, they can have very variable lengths of antenna, but the stonefly, as you can see, they're almost the same length as the 2 tails at the end of the body. You'll also see that we have a pair of developing wing pads. And especially this organism on the bottom, it's particularly obvious and very dark. Oftentimes we don't have that available at our disposal to help make an identification. Sometimes it's a little bit, it blends more into the rest of the body, like the organism on the top. There is also variability in how stoneflies present themselves. So on the left, this is a common stonefly. It's called a common stonefly because it's probably the most common stonefly that we'll find. But on the right, this is a Pteronarcidae, and this is another type of stonefly, but it's just kind of bulkier and has these interesting kind of protrusions along the side of the abdomen. We don't want to confuse those with gills along the side of the abdomen. So in this image on the right, we have this hardened plate sticking out of the side of the abdomen. But if you look closely, underneath the third pair of jointed legs, you can kind of see a bit of the gills sticking out. And this is coming from the thoracic segment. So it's got those hairy armpits, which is indicative of the stonefly. And another thing to look for, if you are saying, are those abdominal gills? Are they not? You can look at the tarsal claws. Again, we have a pair of toes at the end of the leg, while a mayfly will only ever have 1 tarsal claw. This is another funky one. This one is called the roach-like stonefly because it kind of looks like a roach. This shows us the variability in how those gills, those thoracic gills, can present. Typically, we'll see them sort of branchy, cottony, sort of looking gills. But with this particular family, we'll see they're forked and they're kind of one unit. They're not so fluffy, but they are gills, and they are so-called hairy armpits still. So in our Placoptera order, we have a few options, 5, 6, 7, 8 different families that we might find in the Placopteran order. And again, we'll go over these on Saturday. So what I'd love for you to focus on kind of between now and then is getting to know these orders. And I'll give you some tools at the end of this presentation to kind of help you study the orders themselves, because we're going to dive deeper on Saturday into the families. Damselflies are part of order Odonata. They share this order with dragonflies. So damselflies and dragonflies are within the same order. If we were to stop at the order level, we would be counting them as exactly the same. But for our purposes, we're going down to, of course, we're going down to family eventually, but the damselflies fall into a suborder called Tricoptera. What's interesting about the damselfly is it kind of looks similar again to the mayfly larva. We have the head capsule, we have the thorax with 3 pairs of jointed legs. We have the abdomen, and we have 3 what looks like tails at the end of the body. Now, those tails at the end of the body are not in fact tails. Those are its gills, and they tend to be a little bit wider, more paddle-like. And sometimes those gills can fall off as well. So we want to have something else to rely on to make our identification. One huge thing that differentiates the damselflies and the dragonflies from everything else is this very enlarged lower labium. So you can see on this picture, we've got, it almost looks like a mask covering the bottom of the face. So we're looking at the ventral side of this organism, or the underside of this organism. The eyes are on the back, and this is its lower lip. And in this image on the right, we can see that lower lip as it extends out. So when you are looking at an organism, you can take your forceps under the microscope and kind of very gently pull that jaw out. And if you see that it has that extending jaw, that prehensile labium, then you're certain that it's either a damselfly or a dragonfly. Damselflies are fairly slender along the body, so they're pretty thin. And those gills at the end of the body can be very wide and paddle-like, or they can be sort of thin and look more closely related to the tails. So here's what they might look like in person. In the top, we have those the gills at the end of the body, the quote-unquote tails that are wider. And with this damselfly on the bottom, we have very thin tails. So again, if we're wondering, is this a mayfly? What are the things we're looking for? We do not have gills along the side of the abdomen here. Also, if we were to flip this organism over, we could pull out that prehensile labium, that jaw, to say, okay, mayflies definitely don't have this. We have to identify this as something else. Another thing is that the damselflies will have 2 tarsal claws, so 2 toes at the end of each jointed leg. And here is a look at a beautiful damselfly collecting a Culicidae, or a mosquito larva, underwater, which is great. I love that they eat mosquitoes. Unfortunately, when we preserve our organisms, we can be a little rough with them. And you saw that, you were out in the field, we're kind of scrubbing those rocks, really digging our nets into the vegetation and things. And that means that sometimes the organisms can lose parts. So in the organism on the top here, this damselfly has lost, it looks like 2 of its gills, or 2 of its quote unquote tails. So, again, we just want to make sure that we are looking at other things. We're not just focusing on one thing that we think differentiates this organism. We have to have a whole toolbox to rely on. So on your data sheet, all of the Odonata, the damselflies and dragonflies, are in one section. Now the Calopterigidae, Coangrionidae, and Lestidae are our damselflies. We will go into the dragonflies next. Now the dragonflies they have that lower labium, they have that lip that you could pull out, but the dragonflies tend to have more of a wider abdomen than the damselflies. You can see, so we looked at that image of all of the different damselfly body shapes. Here, they're a little bit more rotund at the back, and that's not an insult to the dragonfly. It's beautiful. Also at the end of the body, we have 3 spikes coming off of the end of the body. Sometimes they can be very, very obvious, like in this example on the top right, 3 very long spikes. But on the example here in the bottom center, the spikes are not very obvious. So sometimes you do have to look a little bit closer to see if it does have those spikes. That said, the dragonfly is maybe the only organism that you'll find that has that lower labium and has this particular body shape with these very developed wing pads. So that identification should be fairly easy. And because I just think it's cool, here's a look at the dragonfly feeding. The sizes and the body types can vary. So up on the top here, we have this very rounded abdomen with the 3 spikes. And on the bottom, we've got, it's more elongated, but still rounded abdomen with very obvious spikes at the end of the body. And take a look at these wing pads. So on the bottom, we have a pair of developing wing pads. These are very obvious. They look a little bit different than they did for the other organisms we've seen. Those wing pads were kind of more triangular and coming off of, in these kind of steps along the thorax. These are kind of look more like strips, but these are still wing pads. So when we're going through a key to identify what these wing pads look like, this is what we're looking for. You'll find that for some of the organisms, the wing pads are harder to identify. So in the specimen on the top, wing pads really are not obvious to me as I look at this picture, but we'll be dealing with the organisms in real life. So we can put them under the microscope and kind of poke it and pull it around to really get a closer look at the wing pads. And again, here's just more of the variability of dragonflies that we might find. This image on the left, many people will see this particular type of dragonfly and say, it's a spider, because it kind of has that rounded body with the legs coming out. Well, first of all, spiders have 8 legs. Dragonflies will only have 3 legs. And say it with me, you flip it over and you pull out that prehensile labium, and that's going to confirm that you do in fact have a dragonfly larva. Now on our dragonflies, there are 4 options for us to choose from that are most commonly found in New Jersey. And so when we're looking at the families, there are different particular body parts that we're going to focus in on when we're making our differentiations between different families in one order. It could be looking at particular segments on antenna. Is the first segment of the antenna much longer than the following segments? It could be that there might be a ridge along the tails that we're looking for. We might be looking for the mouth part, so we'll have to turn that organism over and look more closely at how that mouth is shaped. There's all these different ways to help us make these identifications. All right, moving on to the next order. This is our caddisfly order, or Tricoptera. The caddisflies have that similar insect body shape. 1 head capsule, 3 segments along the thorax. Each of those segments has a pair of jointed legs, so we have 6 total legs. We have a very fleshy abdomen. It kind of looks like a caterpillar sometimes. It's like really big and juicy. And then at the end of the body, we have a pair of prolegs, each of which have 1 claw on the end. So you can see, look at these tiny little prolegs on the end of the body. And if you were to zoom in, you could see a very tiny little claw on the end of both of those prolegs. Something that will help us to identify the specific families of the caddisflies are looking at the plates on the thoracic segment. So just to kind of get you thinking in that way, this particular specimen only has one hardened plate. So we see the head capsule here. This first thoracic segment has that hardened plate, and then the next two segments are fleshy. So that's something we kind of want to keep an eye on when we're looking at our caddisflies. Looking at these two pictures, so the one that we just saw, the caddisflies we just saw, had very tiny prolegs at the end of the body. Those prolegs can be quite obvious on other families. With these, they're really sticking out, and you can see the claw also at the end of both of those prolegs. And we see also that both of these specimens have just one hardened plate just below the head. We'll make sure that we note that. What's interesting about the caddisflies is that their legs can be very different. Like each pair of legs can look very different from the next pair of legs. So you'll see in the top picture, the second and third pair of jointed legs, they look just like your typical jointed legs. They kind of have this elbow action going, and we have similar sizes for each of the parts of the leg. But up top, we see these two kind of things coming out the side. These are actually its first pair of legs, and they're very stunted. They're very small. They may not have the same joints, but we would still consider it to be jointed legs. And I'll show you why that might be in just a second. With these caddisflies, again, it's very obvious. We have these three pairs of jointed legs, but the first pair is very close up to the head and very small. With these caddisflies here, you can see we have like a range of colors. The caddisflies have a lot of diversity in the order. And they can also have hairs that come off of the side of the abdomen. These hairs and their tiny little first pair of legs are really helpful because a lot of these caddisflies will build a case. They build different kinds of cases depending on the family or genus that they're in. So some families prefer to take little strips of wood and wrap it around in this like long cylindrical sort of case. Others prefer to take bits of gravel or sand, and they excrete this underwater glue that holds these bits of sand together. So if it has hairs on the outside of the body, you can see how that might help those bits to help stick to the body itself to create this case underwater. And so these tiny little legs that are just on the top of the head, they're positioned that way so that the organism can tuck basically everything else into the case and just have these little arms sticking out at the top. And so it is able to maneuver a little bit with these little legs very close to the head. The cases can also be used to make identifications because the cases are specific to specific families. If you've preserved a caddisfly inside of its case, that's great. You don't necessarily have to pull the organism out of the case. You can look at the case itself to make that identification. Now, there's other types of caddisflies that do not build cases or portable cases. Portable cases meaning that they can walk around with it and it's sort of this free case that is going with the body and not attached to anything else. Other types of caddisflies will build nets. So we call these our net spinning caddisflies. The nets are stuck together with little bits of rock and usually adhere to a larger bit of cobble or a larger rock. And so you can see there is a caddisfly here in this bottom picture inside of its net, and it just hangs there and waits for food to float right into its net. It's a kind of lovely little adaptation that helps it to stay stationary and also to be protected from predators. Now there's this is the net spinner. Again, this is our Hydrocyclidae. For the Hydrocyclidae, we have 3 hardened plates. So we see this head capsule, and then 1, 2, 3. This last thoracic segment in the top picture has a bit of sand or, zhuzh on it, but it does have that 3rd hardened plate. We also see that the Hydrocyclidae, or the net spinning caddisflies, will have gills on the underside of the abdomen, on the ventral side of the abdomen, and they can be big and branchy and very obvious. They also have the gills kind of sticking off of the end of the body with that pair of prolegs as well. I'm calling out the Hydrocyclidae specifically from the rest of the caddisflies because it has a very different pollution tolerance value as compared to everything else in the order. So most caddisflies are very sensitive to pollution, and they will not be able to thrive in a polluted environment. But Hydrocyclidae, they have a higher pollution tolerance value, and that means that you'll find them a lot more frequently. Now, there's a 3rd type of caddisfly that does not build a case. It doesn't build a net. These are just our free living caddisflies. So we have our Polycentropotidae on the left and our Philopotamidae on the right. And I just love the colors of these organisms. These in particular will tend to have that sort of orange hue, and they have super interesting mouth parts. So it kind of looks like the guy on the right here, this Philopotamidae, has like a cotton mouth. It's just kind of like, just looks like nothing. But you'll see that we have the same structure. We have the head, we have the thorax, and we have a fleshy body. So on the left here, you can see how we can differentiate hardened plates from the fleshiness of the rest of the body. So this hardened plate, this first thoracic segment, kind of has the same coloring as the actual head capsule. And the same goes for this caddisfly on the right as well. Now there's lots of options within the Tricopteran order. To identify these families, we're looking at those hardened plates. We're looking at the legs. We're looking at the abdomen, if there are seams on the side of the abdomen. There's a lot of different factors that will be taken into account when we go to identify the actual families. Now moving on to something that's a little more simple, a clam. I think we've all seen a clam or a mussel. This is in the class Bivalvia. We will typically find just two families of clams in our area, the Corydalidae and the Scialidae. So the Scialidae is the image on the left here. This is what we call a fingernail clam. So it's very small. It kind of looks like your fingernail and it has a smooth edge. The other very common clam that we'll find is this one in the center. This is the Asiatic clam, or the Corydalidae. It's a little bit darker and has deeper ridges along the shell itself. Now, you may also find freshwater mussels in your stream. Freshwater mussels this is sort of a complicated topic, and I don't think that we've actually decided, what we're going to do about when we find a freshwater mussel, if we preserve it or if we just leave it and note its presence, because we have a lot of endangered freshwater mussels in our streams. So if you find an organism that has this dark or oblong sort of shape and it's larger, that's very likely going to be a freshwater mussel. The clams are more like maybe an inch or smaller. The freshwater mussels are much larger. So we'll have to come out with a policy, I think, to guide you if you do find freshwater mussels. But just keep in mind now that if you find one, don't preserve it, but take a picture of it and let us know how many you find. And that should be sufficient for our data sheet. With our snails, this is in our class Gastropoda. There are two general types of aquatic snails that we'll find. We have snails that are lunged, or that breathe air. So they come up to the surface, they take a big gulp, and then they can kind of float back down and hang out underwater, and they come back up to breathe and come back down. These lunged snails are typically left-handed. So what that means is when you have the top of the snail facing up and the opening of the snail below, if the snail opens on the left-hand side, we call that a left-handed snail, and that is a lunged snail. It also does not have an operculum, which is kind of a hardened shell that covers this opening. So you can see this, I think that's a Physidae, but you can see the fleshiness inside. So there's no operculum on these lunged snails. The gilled snails, on the other hand, are right-handed. So you can see we have the opening on the bottom facing us. We have the opening on the right-handed side. The gilled snails do have an operculum covering that shell opening. So it may look a little bit harder. You won't be able to actually see that soft tissue inside. Now, the gilled snails, they have gills, so they breathe dissolved oxygen underwater. And the gilled snails tend to be more sensitive to pollution issues because they rely on dissolved oxygen and don't have to come up to the surface to breathe. Now, with our snails, there are a few different options. If they're lunged or gilled, they all fall into this category. These are the options that we will most likely find. And I just want to mention the Scialidae, the limpets. Do we have a picture back here? Sort of. So here, this limpet, it has one hardened shell that's flattened, and they're usually attached to rocks. So when you pull it off and it goes into your net and you preserve it, sometimes people will confuse these for clams. But the thing that's very important to remember is that clams have a hinge. So they have two shells that come together and they can close. The limpet only has one shell. And if you flip it over, the fleshy guy is right there. There's no hinge, no bottom part of that shell. So the limpets are considered in the snail group, the Gastropoda, and we would record those here. Our next order is our Scuds, or order Amphipoda. Scuds sort of resemble shrimps. They have this like curved body. They look very much like a crustacean. Sometimes they're referred to as side swimmers. So they're laterally flattened, which means they're flattened from sort of side to side. If you look at them head on, they're very skinny. And they're usually flipped on their side and swimming around on their side, hence the name side swimmers. They have 7 pairs of segmented legs along the body, and the head is sort of fused with the first thoracic segment. So here's what they look like in person. This is just in the palm of someone's hand. They're quite small. They can vary in color. They can be dark brown to black. They can be orange. They can be white, yellow, kind of all shades in the middle there. But you'll see we have these 2 pairs of antennae and the 7 pairs of segmented legs along the body. We do differentiate between 2 families of Scuds. And I included this picture just to kind of show you the kinds of things that we would be looking for a Scud. So to differentiate the families, one of the ways we can do that is number 11 on this image on the left. This is referring to the telson. So this is just an appendage at the back of the body, right above the end of the abdomen. Now that telson can sometimes stick out, but it's quite small. Number 12, this is the telson that is indicative of the Gameridae family. On the right, 13, this is the telson that's indicative of the Crayfish family. So, whether that telson is sharply divided up to the top or whether it's sort of fused at the top. These are the sort of little features we'll be looking for when we are working in the lab. It may seem like a lot to absorb, right up front. If you're not an entomologist or a freshwater biologist, and I'm coming at you and saying, look at the telsons and look, are they sharply divided? That's a lot of information. But we will give you the resources to help you make these identifications. We'll prepare binders for you with all kinds of keys. So hopefully we can make this as easy as possible. The next order is Isopada, and this one is fortunate for us. There's only one family that we might find. So this is a relatively easy identification, family Scialidae. Sow bugs are like pill bugs or potato bugs or isopods, whatever you might call them. Rather than being laterally flattened from side to side, they are dorso-ventrally flattened. So from top to bottom, they're sort of flat. They also have 7 pairs of segmented legs, 2 pairs of antennae, just like the scud, but the isopod will have a very enlarged final segment of the abdomen. So while the scud had this sort of curvature, you could see the telsons sort of sticking up a little bit at the back of the body. The isopods, the Scialidae, the sow bugs, will have this enlarged final segment back there. So that should be pretty indicative of the sow bug. And again, just one option on the data sheet. The crayfish, this is another crustacean that we will find. I think we're all familiar with the crayfish. Looks like a crayfish, looks like a little lobster. The head and the thorax are fused. It has 5 pairs of segmented legs. The first pair are those pincers. You may opt not to preserve the crayfish when you're out in the field. DEP actually follows that procedure. They do not always preserve the crayfish in the field for a lot of different reasons. But if you choose not to preserve them in the field, what you should be doing is taking a picture of this organism. And when we then go to subsample, when you're back in the lab, we will find a rock or something that we will indicate as the crayfish in your sample. And we will still put it in your tray and we'll subsample just as we would with any other organism we might find, except it's a rock instead of a preserved crayfish. So we want to make sure we're maintaining this random subsampling without, if you choose not to, you don't have to preserve the crayfish. But this is a relatively easy one. Typically, the crayfish will fall into the family Cambaridae. Here we go. Our next order, we're getting into the Megaloptera order. There are 2 families that fall in the Megalopteran order. The first is Corydalidae. These are the Hellgrammites or Damselfflies. These can be quite large and very dark, and they kind of look scary in person, to be honest. At the top of the head, we see that it has this enlarged jaw. These help it to chew other animals because it is a predator. So it has these very large mandibles up top. It has 3 pairs of segmented legs. And then it has 8 pairs of lateral filaments, or just kind of, it looks like tails, but coming off of the sides of the abdomen. Instead of tails, at the end of the body, we have a pair of prolegs. Each has a pair of hooks. So sometimes people will look at this organism and say, holy moly, it has so many arms or legs. It might be a sow bug, because the sow bugs also have 7 pairs of legs. This one, we want to make sure that we differentiate between these jointed legs along the thorax and the filaments along the abdomen. So the filaments should look a little different to you. The jointed legs have the joint. They have more of that structure. They have the 2 toes at the end of the leg. The filaments are just pointy filaments coming off of the side of the abdomen. And also the sow bugs are relatively small. I'd say an inch or smaller, while the Damselfflies are very large. So, in relation to this person's hand who's holding them, you can see really how big they can get. But those jaws are very obvious. See them at the top of the head. And sometimes the Helgermite or Damselffly will have gills along the abdomen as well. But since you'll see the gills in conjunction with the lateral filaments and that huge jaw, you'll be able to make that identification. So the Corydalidae was the first of the megalopterans that we reviewed. Next, we'll go to the Scialidae, or the alderflies. They sort of look similar to the Damselffly, but when you see them in person, you'll find that they are much, much smaller. So the Corydalidae, the Damselfflies, can be like, 5 inches long, very dark. The alderflies really only get to about an inch long or smaller. Oftentimes they are smaller than that. They do have the mandibles. They do have the powerful jaw, but because it's so small, it doesn't seem as obvious to us as it does with the Damselffly. It also has the 3 pairs of segmented legs on the thoracic segments, and then 7 pairs of lateral filaments along the abdomen. So again, similar to the Damselffly. But while the Damselffly has a pair of prolegs, each with a pair of hooks at the end of the body, at the end of the alderfly abdomen, we just have one single long filament, or one tail at the end of the body. So here's another look at some different types of alderflies we might find. We have the 7 pairs of filaments coming off of the side of the abdomen and the one tail. So this identification, choosing between the Damselffly and the alderfly should be pretty easy and straightforward, I think. Now we are moving into some families that we'll find. So there's 2 orders, the Coleoptera, which are the beetles, and the dipterans, which are the true flies, where the orders we've looked at so far have had the families have a lot more in common with each other. They have some similarities that allow us to look at the order as a whole and say, this is a mayfly. We're not able really to do that with the coleopterans and dipterans because there's so much diversity in the way that the bodies present. So with this next part, I'll just go over a few of the most common families that we find in these orders. By no means is this an extensive list, but this is just sort of an introduction to the things we will very likely find. And then I'll show you kind of, oh, here we go. Here's a list of all of the coleopterans that you might find. This is not an extensive list either. We will likely find more options than this, but these are the most common types of beetles. What's interesting about the beetles is that with the other organisms, mayflies, stoneflies, caddisflies, alderflies, Damselfflies, we are only looking at the larval form of this particular organism. We're looking at the juvenile phase. With riffle beetles, or family Elmidae, we will find both the larva and the adult phases underwater. So the larvae do not come out and become terrestrial as an adult, they remain underwater. Now the riffle beetle larva, as a larva, is very, very small, up to a ½ inch long, likely smaller than that. They're dark brown to black in color. They have that hardened plate all down the entire body. So think about the caddisfly and the hardened plate just on the head, just on a few segments of the thorax. This hardened plating goes all the way down to the end of the abdomen. It has 3 pairs of segmented legs. Sometimes these legs can be very tiny and small. But if we're using our microscope, we'll be able to see that they're there. They also have very tiny antennae. At the end of the body, they have an operculum, which means that they can open it up and expose the gills at the end of the body, or they can close that operculum and you won't see any gills. So in this particular example, we can see that the operculum is open and we can see these gill filaments sticking out at the end of the abdomen. Here are 2 other Elmidae larvae in comparison. On the top, It looks like it's just a pointy bit at the end of the abdomen, but that's because the operculum is closed. On the bottom, this is a different genus or different species of riffle beetle. But also you can see that the operculum is open, and so those scales are exposed. But it has a similar body structure with both of these. We have the head, we have this hardened body along the full stretch, and the 3 pairs of segmented legs. There is another type of beetle that does look similar to the Elmidae, and for this, we would be looking at, you see this like white stripe almost along the side of the abdomen. This is something that we would be looking for to make that differentiation. Now with the riffle beetle adults, they're very small, even smaller than a 1/2 inch. They can be 1/8 of an inch, a 1/16 of an inch. They will look like a beetle. So they have the head, the fused thoracic segment, and the abdominal segment as well, with 3 pairs of jointed legs. And we don't find very many adult beetles underwater, so that should be sort of an easy identification as well. The water penny beetles, this is a type of beetle where the adult does come out of the water, so we probably won't be finding the adults in our sample. But the larvae have a very distinctive body shape. So it's called a water penny because it kind of looks like a penny. When it adheres to a rock, if you're looking at the back of it, it has this like copper hue and blends in with the rest of the rock. But if you flip that organism over, you'll see that it sort of looks like a mayfly on the underside. It has a head, it has 3 pairs of legs, it has the gills along the abdomen, but it just has this enlarged sort of plating on the back that helps it to blend in very well in its environment. So this is commonly what we'll see on our cobble in nice habitats. In high water quality, we'll find water penny beetles all over rocks. So we'll probably find a lot of these. In the dipteran order, or the true flies, there are many more true fly families than what are listed here, but what are listed are just the most common. You will find that there are blank spaces on the data sheet. So if you are looking at something and it does not fit any of these categories, that's okay. You'll be able to use the tools that you have to identify what that organism is and just write in the family that you actually find. But for this, we'll just go over the most common. The crane fly is family Typulidae. They also can be quite large, up to maybe 3 inches or so long. They look sort of like a caterpillar. They have that plump appearance, but they have a rounded head. And at the end of the body, we have finger-like spiracles that extend off of the end of the body. So these are these kind of, fleshy protrusions at the end of the abdomen. Here's another look at the crane fly. What is interesting about the crane fly is it does have a head capsule, but oftentimes it's sort of pulled back into its body and covered by the fleshiness of the body. In this image on the top, you can see the tiny little antenna sticking off of its tiny little head. But we have primarily, you'll find just kind of a rounded bit at the head. You may not see the head at all. These segments can be pretty deep, so deeply segmented, meaning that you can really count how many segments this organism has. The spiracles, again, are at the end of the body. You can see these here. This is the end of the body. And sometimes the crane fly will have interesting bits on it. So it's still a Typulidae. We would still identify all of these options as a Typulidae. But of course, there's different genera we'll find, different species that we'll find. So they can present themselves in different ways. Could have an enlarged final segment of the abdomen. So you kind of see here, it's more bubbled up at the end, just before the spiracles. Or The cranefly, the Scialidae, could have these creeping welts. So it's like a proleg of a proleg almost, that kind of can help it maneuver around. Black flies are another type of dipteran that we'll find. This is in family Scialidae. The black flies, the head is on the top here. It is we kind of call this a bowling pin. It has bowling pin shape. So it's kind of thinner at the top and is more bulbous at the end of the body. The black fly has a single proleg below the head. So in this image on the bottom, you can see this very distinctive hardened head capsule. Underneath that, we have this single proleg, and then it gets wider and wider and wider as we go down the abdomen. So up at the top of the head, the black fly has some interesting mouth parts. Sometimes the mouth parts are not very large. Again, we have diversity, different genera, different species within the Scialidae or black fly family. So sometimes the mouth parts will not be very obvious. Other times we will find these very obvious wide fans attached to the top of the head. It's really interesting the way that they feed. They attach themselves to the bottom of the stream and just sort of float in the current and use these fan bits to capture fine particulates from the water column. The midgefly larvae, though, have a much less distinctive head, but it is still a hardened capsule. So in this example here, this is a blood red midge or blood red Chironomidae. We do differentiate between blood red Chironomidae and everything else, which are usually white or maybe a light yellow. The blood red midges, we differentiate because they can serve, their pollution tolerance value is higher. So we want to make sure that we pull those out and identify them separately. The midge flies have a pair of prolegs below the head and a pair of prolegs at the end of the body. So here we see the head capsule on this top specimen, a pair of prolegs, two prolegs just underneath, and then a pair of prolegs at the end of the abdomen. We see the same thing on the specimen on the bottom. Pair of prolegs here, pair of prolegs at the end of the body, but the head will sometimes show up a little bit differently. So this head is much smaller in relation to the rest of the body size. Here's a look at the different options we might find, the variability in Chironomidae we could see. We see different sizes of midges. We see different colors of midges. They sometimes will have kind of different shapes. Sometimes they preserve and they're stick straight. Sometimes they preserve into this like curvature sort of shape. They're all midges if they've got that hardened capsule head, a pair of prolegs under the head, and a pair of prolegs at the end of the body. Lastly, we'll look at some organisms that we will not identify to family. We don't even identify them to order. We will stop at the class level. So for aquatic worms and for leeches, we just need to identify that they're aquatic worms or leeches, and we don't need to go any further than that. Makes it a little bit easier for us. So the leeches on the left, they are flattened from top to bottom. They have deep segments along the full body. And of course, they have the suckers on both ends. While the earthworms are more cylindrical, they're also segmented through the length of the body. They could have little short hairs sticking off, and they come in a variety of different colors. But with the leeches, since we're at class, you've got order, family, genus, species below that, there's tons of variability with the leeches. So we might find that they're kind of short and stout and white and just sort of look like a blob. Or we might find that they're very long and dark and larger. Lucky for us, or maybe, I don't know, maybe you want to identify leeches. If that's the case, let's talk. But it's easier for us on this data sheet to just stop and say, It is a leech. It has the two suckers, deeply segmented body. And because I'm a sucker for leeches, here's a GIF. Just beautiful. We love it. Now, aquatic worms can come in a huge variety of sizes and shapes and colors. Sometimes they can be very plump and look like your typical earthworm, that sort of pinkish color. Sometimes horsehair worms are so thin. They're so thin. And when they are preserved, they lose their color. So they just kind of look like little kind of curlicues in your sample. Hopefully we find some of those on Saturday so we can pull it out and get a feel for how these aquatic worms preserve and how they look in your sample. But this is how it looks on your data sheet. We have under Algochaeta, aquatic worms. That's as far as we'll go for our identifications. Now, did we miss anything? Of course we did. Yes. I didn't teach all of aquatic entomology in an hour and 8 minutes. There's lots of other organisms out there that we'll find. Here's a little snapshot at the different options we'll see. Up at the top, this is the crawling water beetle, or the Haliplidae. We call them little spiky dudes. This is part of the beetle group. We could find horsefly larvae, the Tympanidae, which has pointy ends on both sides of the body. So you think about the rounded edges on the cranefly. This is pointier at both edges. We could find Planaria, which has this triangular head, these beautiful little eye spots. Sometimes people will confuse them for leeches, but we're looking for that triangular head. We'll definitely see the eye spots. And we could find water boatmen, water striders, other specimens in the hemipteran order or the true bug order. Typically, those organisms are lunged, so sometimes we will not include them in our sample. In other groups, for us, we do include them in our sample. We'll count each hemipteran or true bug that we find. Or we could find mosquitoes. The Haliplidae is an option that exists both in its larval and its adult phase. So in the larval phase, it's in the upper left corner. Its adult phase is in the lower center. We may also, depending on the time of year, we may find pupa in our streams. If we find pupa, and sometimes people will kind of look like this image on the top right, this is a midge pupa. They almost look like they have a little, like a helmet that comes on the top of the head. They look like aliens, really, when you look at them under the microscope. For the pupa themselves, we do not count them in our sample. So any pupa, it's harder to make that identification. We'll pull them out, put them aside. Unfortunately, we will not add them in our total. So, just to give us a little bit of practice before we really dive in on Saturday, I wanted to introduce you to a very basic dichotomous key. This is a key that was produced by the Stroud Water Research Center. It's commonly used for groups that are doing stream side identification. So if you're not preserving, you're just identifying there and releasing the organisms back into the stream, this is a common key that you'll use. So I figured we'll take a moment and try to identify this organism on the left. What do we have here? So dichotomous keys are basically like a choose your own adventure story. You start at the top and there are questions along the way. The first group of questions on this particular key are, does this organism have jointed legs or no jointed legs? And that's going to help us, right off the bat to try to figure out what this guy is. Now I'm looking at him, or her, excuse me, and I see that we do have jointed legs. In fact, we have 3 pairs of jointed legs. I'm seeing 6 legs. So we can say, yes, we do have jointed legs on this organism. And yes, indeed, we do have 6 jointed legs. So we're turning the metaphorical page over to page 3. Now, when we get there at the top, yes, we have 6 jointed legs. We're in the right place. The next question is, do we have a portable case attached to this organism or no portable case? Looking at you, I do not see a portable case. Okay, so I'm going to the no portable case section. And then the next question is, do we see wing pads on the body or do we not see wing pads? So I'm just going to change the contrast a bit. Hopefully this helps kind of with our identification. We do see these triangular bits sticking down on the bottom of the thorax. These are in fact wing pads. So we can go to page 4 of this key. So yes, wing pads or wings present, excellent. The next question on this key, do we have tail filaments or no tail filaments visible? For this, we'd see that we do have 3 tails coming off of the end of the body. Now, once we get to that section, we can choose between 3 options. The first option says, do we have 2 tail filaments without abdominal gills? No, we don't, because we have 3. Okay, the next option, do we have 2 or 3 tail filaments with abdominal gills? I'm looking at him and I see we have this fluffy bit along the side of the abdomen. That looks to me like abdominal gills. We have 2 or 3 tail filaments at the end of the body. Amazing. We have identified this as a mayfly. This is an ephemeroptera. So you can see on this key, when we're looking at tail filaments, it adds damselflies in the same category. We already know that those tail filaments are not in fact tails, they are gills at the end of the body. Sometimes these keys are designed more to make them accessible to people. So rather than you having to know that those are gills as opposed to tails, this key will still help you just visually look at the organism and go along your way. Some keys are not as forgiving on you. So with the key that we will provide on Saturday, we use a key called Aquatic Entomology from the textbook Aquatic Entomology by McCafferty. And this kind of starts, there's a huge introduction into how to do the identifications. The glossary has been printed for you. So as you're going through the individual keys and keying through, and it might say, does it have an operculum? Does it have, I don't know, whatever. What did the telsons look like? That glossary will be available for you to check back and kind of look back at the key, look back at the glossary, and that should help you along your travels. Another thing that I think is a useful tool in the meantime, before Saturday, is macroinvertebrates.org. This is an excellent tool. It's a newer website. It has all of the different taxa that we'll find listed and with very close-up photos of all of the different parts of each specimen. It also has a practice test, which is pretty cool. So you can go in and kind of test your knowledge on the orders before we dive a little bit deeper on Saturday. Okay. Now, I am going to stop our recording and ask if there are any questions.